And this question says a curve is represented by x is 1 plus 3t and y is t squared plus 7t. O is the origin and x is the point on the curve such that the gradient of OX is 1.5. So the gradient from O to X is 1.5. Find the possible values of the parameter t at X. So if the gradient of OX is 1.5, the gradient of OX is y2 minus y1. That's how we find gradient y2 minus y1 over x2 minus x1. This is how we find the gradient, but what did they tell us? The x-coordinate and the y-coordinate at the point x is given by these parameters. So y2 is going to be t squared plus 7t. And then what is the y-coordinate at the origin? The y-coordinate at the origin is 0. Always remember that the origin O has coordinates 0, 0. That's at the origin. So it is t squared plus 7t minus 0 over x2. The x-coordinate at x is 1 plus 3t. And then we minus x1, where x1 is 0. All right, and what did they tell us? The gradient of OX is 1.5. Gradient of OX is 1.5. That is 1.5 is 3 over 2. Now we're just going to cross multiply and solve for t. So that implies when we cross multiply and solve for t, we're going to end up at 2 times 2t squared. So it's 2t squared plus the 2 times 7t is 14t. And that is now equal to, we cross multiply 1 plus 3t times 3 to get 3 plus 9t. So what can we do now? We can bring over the 9t to one side and we get 2t squared. Bring over this 9t, 14t minus 9t is 5t. This is 5t. And then we bring over the 3 over here to get minus 3. And this is equal to 0. So looking at it now, all right, looking at it, this is it. We solve this equation now and we're solving 2t and t. Signs are different, but the bigger product is negative. So we put the 3 right here and the 1 right here. This is plus, this is minus, this times this, 60, that's right. So what we're getting is the 2 possible values of t are t equal a half and t equal to negative 3. That's the 2 possible values of t for this question. All right, nice and easy, soft. So that's the possible values at t at the parameter x. Now, of course, it's always good to look at this on an actual graph. So let us plot a graph and see what is happening. We're going to plot a graph and see what is happening. All right, so let's go to this graph right here. So we're going to plot a parametric function. Remember, we had said that x was what? 1 plus 3t. And we said y was t squared plus 7t. So we're going to plot this now. All right, so zoom out a little bit. This is what we have. This is how the curve is looking like a quadratic curve. All right, the origin, remember, is O. All right, so let's look at this now. I'm going to show you that the gradient is 1.5. So remember, x is 1 plus 3t. And look at this. If we put t as a half, we can find the corresponding coordinates that x can be, right? What would be the corresponding x coordinates? All we have to do now is put a half into this, and so we have 1 plus 3 times a half. 1 plus 3 times a half is 2.5. So the one possible x coordinate is 2.5, comma, the y coordinate would be a half square plus 7 times a half. So a point is 2.5, 3.75. So this is one possible x coordinate. This is a possible x coordinate, possible. Another possible x coordinate is when t is minus 3. When t is minus 3, another possible x coordinate is putting minus 3 in here. 1 plus 3 times minus 3 is negative 8. And the y coordinate is negative 3 squared plus 7 times negative 3, which is negative 12. And you might say, sir, why are you doing this? I'm going to show you that the gradient from the origin to these points is 1.5. And so these are the answers for t. These are the answers. I'm just verifying that the answer is true. All right. So the answer is t equal 0.5 or t equal negative 3. That's the answer. And we're going to verify these, of course. We have to. That's the answer. All right, so let's verify it. So going back to the graph, as I really want to show right here, if I'm going to plot the points, let's insert the points, insert points. I'm going to insert the point 0, 0, and one possible x coordinate we said was, what was that? We said one possible x coordinate could have been, let's look back at it, 2.5, 3.75, 2.5, 3.75. And another possible x coordinate, x point is negative 8, negative 12. Negative 8, negative 12. So let's have a look at this now. So I'm plotting in these. So that is that. Now look at this. What I'm going to do is draw a line of best fit passing through those points. That's a line of best fit. For this line of best fit, look at it. The gradient of that line is 1.5. Here it is. It tells us that the function would have been 1.5x. Right? Look at it good. From the origin to this point, x, this is one possible point for x. The gradient would be 1.5 right here. Gradient is a rise of, this is a rise of 12 over a run of, or rise of 12 over run of 8. 12 over 8 is 1.5. This gradient is 1.5. The gradient from origin to this point as well is also the rise of 3 over the run of 2, which is also 1.5. All right, so yeah, this is just verifying that the gradient is 1.5. All right, so therefore when t is indeed equal to a half and negative 3, we get that the gradient is 1.5 from the origin. So that's verification of this answer. Next part, it says obtain an expression for dy by dx. To find dy by dx, you just have to remember that dy by dx is equal to, for parametric differentiation, dy by dx is dy by dt multiplied by dt dx. It's dy by dt times dt dx. Now to find dy by dt, We're going to differentiate y with respect to t. Differentiating y with respect to t, we get 2t plus 7 times dt dx. dt dx is 1 over dx dt. And dx dt, when you differentiate this, you get 3. So dy by dx is equal to 2t plus 7 over 3. That is it. dy by dx is equal to 2t plus 7 over 3. Easy. Next question says, P is the point on the curve with parameter -2, and Q is the point with parameter -5. The tangents to the curve at P and Q meet at R. Find the coordinates of R and the area of the triangle PQR. Now, P is the point on the curve with parameter -2. So let's find the point P. So we can write at P, what do we know? We know that T is equal to -2. And so we can find the coordinates of P using this. Remember, x is 1 plus 3t. So we can find the x coordinate. X is equal to 1 plus 3 times t, which is -2. So the x coordinate is 1 plus 3 times -2, which is negative 1 plus 3 times -2, which is -5. That's the x coordinate at P. And then we can find the y coordinate at P, and it is t squared plus 7t. So this is going to be, finding the y coordinate now is t squared, which is a half, -2, sorry, t squared plus 7 times -2. We work that out. -2 squared plus 7 times -2 is -10. So that's what we get. So P is the point, P is the point, -5, -10. All right. Now, look what they said. They said the tangents to the curve at P. So we need to find the equation of the tangent at P. So to find the equation of the tangent at P, let's make them. All right. So the equation of the tangent at P, so we need the gradient at P. So to find the gradient at P, we need to find dy by dx at P. Now at P, dy by dx is equal to 2t plus 7. So it's going to be equal to 2t, t is -2, 2t plus 7 divided by 3. And we divide that by 3, and what we're getting is 2 times -2 plus 7 divided by 3, which is 1. So dy by dx equal to 1. Since dy by dx equal 1, then the equation of the tangent, so the equation of the tangent at P, equation of the tangent at P, the equation of the tangent at P is given by, this is the equation of the tangent, y minus the y value, so it's y plus 10, and that's equal to the gradient of the tangent, which is dy by dx, which is 1, times x minus -5, which is x plus 5. So what we end up getting is y is equal to, this look like x plus 5, and we'll bring over the 10, it becomes y equal x minus 5. So that's the equation of the tangent at P. Now we need to find the equation of the tangent at Q. What do we know about Q? At Q, the parameter t is -5. So at Q, t is equal to -5. All right, now look at this now. X is equal to 1 plus 3 times -2. That works out to be 1 plus 3 times -2. That's also -5. Oh, my apologies, t is -5. So it's 1 plus 3 times -5. 1 plus 3 times -5 is -14. And we can find y. Y is now t squared, which is -5 squared plus 7 times negative 5, and that is equal to negative 5 squared plus 7 times negative 5, that's negative 10. So that's your coordinate at Q. So now we can write down that Q is the point, negative 14, negative 10. All right, that's what we want. Since this is the point Q, all right, since this is the point Q right here, we're really nice. Because guess why we're nice? We're nice because we know that dy by dx is going to be equal to 2t. So it's equal to 2 times our negative 5, 2 times our negative 5, plus t, 2 times negative 5 plus 7 over 3. That works out to be 2 times negative 5 plus 7 over 3 is negative 1. This is negative 1. So the gradient of the tangent at Q is negative 1. So the equation of the tangent is going to be given by the equation of tangent at Q is given by y minus or y value. So it's y minus minus 10, which will become y plus 10. And that's equal to the gradient of the tangent of negative 1 times x minus your x value at Q, which is x plus 14. And so expanding and simplify, we're going to get the equation of the tangent at Q is y is equal to negative x. Then that's minus 14, and we bring over the 10. Minus 14 minus 10 is minus 24. That's the equation of the tangent at Q. Now, what they told us is that the tangent at P and the tangent at Q meet at a point R. So when these two lines at these 2 points right here, when they intersect at the point R. So let's show, so at R, the two tangents meet. At R, the two tangents meet. At R, the two tangents meet. So since at R, the two tangents meet, what that means is this is what we want to find now. At R, when the two tangents meet, at R, the two tangents meet. Let's see. At R, the two tangents meet. So we equate this line. So y equal x minus 5. And we equate it with this line, y equal to negative x minus 24. Now, I like to use elimination method. So what I'm going to do is add these two equations. If I add these two equations, I would get 2y is equal to x plus negative x gone, minus 5 plus minus 24. So minus 5 plus minus 24, just have to make sure that's minus 29. So what we get is y is equal to negative, let me see, negative 29 over 2. That is y. If y is negative 29 over 2, we can substitute in that for y right here. And so negative 29 over 2 is equal to x minus 5. So we add 5 to both sides. And so x going to work out to be 5 minus 29 over 2. That works out to be 5 minus 29 over 2, which is minus 19 over 2. So that is it. So therefore, we can write down that R is the point, minus 19 over 2, comma, negative 29 over 2. That's the point R. Beautiful. This is the coordinates of R. Now what they want us to do now, it says find the area of triangle PQR. So what I'm going to do is just sketch a little. We're in the third quadrant clearly because all the coordinates are negative. So we're in the third quadrant. So if you're to just put a little graph like this with a third quadrant here, just to picture what is happening, right? Picturing what is happening. P is the point -5, -10. So let's say this is -5 and this is -10. Then this is your point P. This is your point P right here. And then Q is the point -14, -10. So this is P. Q is the point -14, -10. Let's put -14 here. -14, -10 is right here. This is your point Q. And then now they want the point R. Where is R? R is -19/2, -29/2. So -19/2 is -9.5. So that's somewhere right here. All right, -19/2 is somewhere right here. And then -29/2, that's close to -15. So that is somewhere down here. So this is your point R. This is your point R. So we have a triangle looks something like this. And we want to find the area of this triangle. Now, we can just use half base times height and find the area of this triangle. Remember, this is -29/2. Nice. So in order to find the height of the triangle, look at this. This is the height of the triangle. From here to here is the height. Now the base of the triangle is going to be from here to here. So clearly the base is to go from -5 to -14, that's 9. So the base is 9. To go from -10 to -29/2, all you need to do is work out 29/2 minus 10, that is 4.5. So the height of the triangle is 4.5. Height of the triangle is 4.5. And so therefore the area of the triangle, so area of the triangle PQR, we can tell them that area of the triangle PQR is a half the base times the height. And we already know the base and the height, so the area works out to be half base times height, which is a half the base of 9 times the height of 4.5. We work that out, and that will give us 0.5 times 9 times 4.5. We get 20.25. So the area is equal to 20.25 units square. That's the area of the triangle, 20.25 units square. Now, of course, I'm never going to give you a question, and I'm not gonna just work it out and not show you the visual proofs. So I'm gonna go to a graph right here and show you a visual representation of what was happening. So we're gonna get a visual representation of what was happening. So first, let's go to graph. Remember we said that P is the point -5, -10. So we're going to insert that point. We're going to make the color of the point be, let's use a diamond, and we're going to make the color be red. All right. All right, and I want to show the coordinates. So we're going to use, we said P is the point -5, -10. All right, and Q is the point, what is Q again? Q is the point -14, -10. All right, so we plot those points. Oh, I didn't want the line. I don't want this line. All right, so it gave us a line connecting P and Q. That doesn't matter. And this is still incorrect, so let's fix this up a little bit. Y was the point -10, and we don't want no line. Here are the 2 points then. So this is the point P, this is the point P, this is the point Q. Now we're going to draw the tangents passing through these lines, and let's insert the tangents. We said that the tangents we had found were, let's look back at our tangents we found. The equation of our tangents were y equal x minus 5 and y equal minus x minus 24. So let's plug those in. So we're going to plot some function. Insert the function y equal x minus 5. Look at that. X minus 5 passed through our point P. See there? X minus 5 passed through our point P. Now let's insert, just so we can fully see it right here. All right. Now let's insert now. Let's remove some of these stuff. Just to remove this. All right, so just focusing on this is the point P. And now let's insert this now, insert our function. Y equal to, let's use a different color. Let's use burgundy. This is for y equal minus x minus 24. You're gonna see it pass through the point Q, see it there? And they intersect right here. This point that they intersect is Q. That point that they intersect is Q. And look at that, Q is, the x value for Q is the negative 19 over 2. See there, the negative 19 over 2, which is negative 9.5. And the y value is negative, y value is negative 15, negative 29 over 2. All right, so we clearly get the correct thing. This is our point Q. Then what they're asking us to do is to find the area of this triangle. So if we're to draw a line connecting these 2 points, you get the triangle. All right, so I want this point. Let's draw a line now. So we're going to draw a line connecting them. Then we're really finding the area of this triangle right here. The area of this triangle. All right, so that's what we're doing. We're finding the area of this triangle. Now, I am going to show you another app that actually work out the area of the triangle for us. This is a Geometer Sketchpad. We're going to work out the area. All right, so I'm just going to plot down the points again. Remember, P was -5, -10. That is P. Q was -14, -10. That was Q. I'm going to label them. Label points. This is P. This is Q. And we had found that R, which is the intersection point, was -19 over 2. -19 over 2 is -19 over 2 is -9.5. -9.5 would be, this is -9, -9.5 is here. And then we have -29 over 2 for y. -29 over 2 is -14.5. All right, so -14.5 would be going down, going down, going down. This is -30, -40, -50, -14.5 is somewhere here. I'm going to label that point as R. Now, what the geometer sketchpad allows us to do, it allows us to find the area of stuff like these. So we're going to find the area. I'm just connecting them to form our triangle. So this is our triangle PQR. Then what we're going to do is measure the area. We're going to find the area. Look at this now. 1, 2, 3. I want to measure the area. It's not allowing me to find the area. Let's go again. Just shade all of it, measure, not giving me the area. Why not? All right, let's try it this way. That should do it. Measure the area. There we go. Now notice I get 20.65, which is not 20.25. And the reason why we get 20.65 is because the coordinates of R is not accurate. It's not accurate. This is not exactly negative 9.5, and this is not exactly negative 14.5. This is slightly bigger than negative 14.5, slightly bigger than negative 9.5. But it shows you will get the rough estimate. We were roughly correct. 20.65 we get for the area, 20.65 from the graph, but this is the actual correct answer that we work out, 20.25. So that's just verification, easy. All right, so this question says, obtain the Cartesian equation of the curve. So to obtain the Cartesian equation of the curve, remember we had been told x is equal to 1 plus 3t, and we know that y is equal to, what was y? If x is 1 plus 3t, y was, I believe y was t squared plus 7t. That was y. And we need the Cartesian equation. The Cartesian equation eliminates the parameter. So that implies that t is equal to x minus 1 over 3. That is t, x minus 1 over 3. From this equation, t would be equal to x minus 1 over 3. Now we're going to plug the new expression for t in y. So that implies now that y is equal to, replace t with x minus 1, and so y is equal to t minus 1 over 3 squared plus 7t, where t is x minus 1, so it's plus 7 times x minus 1. Now you may want to simplify this, you may want to, but you don't have to. I am not going to, but this is what you get, and this is the Cartesian equation. That's the Cartesian equation. If you want to simplify, that's up to you. That's not what I am going to do.